Welcome, David Sengeh. You can feel free to clap emoji.
Oh yeah, emoji clap.
So David was born and raised in Sierra Leone, and it's a country that suffered a terrible civil war, and as a result, more than 8,000 people have lost their limbs. And David noticed that a lot of people did not opt to wear prosthetics. And when he dug into it and talked to people, he realized that they weren't wearing prosthetics because, or noticed that they didn't have the right fit. So what David has done is that he's pioneered new technology, a system for creating customized prosthetics, which fit onto your residual limb. And the way that he does this is that he uses an MRI to map the shape and uses computer-assisted design to predict internal strains. And with 3D printing, it allows him to use different kinds of materials that are appropriate, right? Yeah, and so he's created sockets that are far more comfortable than traditional models, and these can be produced very cheaply. So it's a really it's very customized and bespoke, but also very democratic, right, in terms of access. So he's able to help and reach so many more people than who would normally have access to these types of prosthetics. So David is a superstar. He has been named one of Forbes 30 under 30 in technology in 2014. And in the same year, he won the Curate Prize. It's a $15,000 prize as part of the Lemelson MIT National Collegiate Student Prize. So welcome, David. Thank you so much for spending time with our community.
Thank you for having me.
Okay, so to kick off, can you tell us about the moment that you decided to make this your life's work?
And by this, you mean like prosthetics?
Prosthetics, yeah.
So when I was growing up in Sierra Leone, one of my mentors still now is a doctor, he's a surgeon, and he would invite me to shadow operations that he did at the theater. And so on any given weekend, we'll do 3, 4 different surgeries. And from when I was, 8, 9, 10, 11. And I always loved shadowing him. So I wanted to be a doctor. I wanted to work in healthcare and technology. And then ultimately, there was an instance where we needed to do some surgery, but he couldn't make a decision because he did not have an ultrasound or some diagnostic tool for which we can decide about the surgery. And that was a point where I thought I wanted to work on medical technologies. So it was not just that I wanted to be a doctor, but I wanted to do medical technologies, things in the hospital. And in Sierra Leone, the path that I would have taken out of high school was to go to medical school and not engineering in that instance. But then I got a scholarship to Norway at the United World College, where I spent 2 years. And that was the first time I heard about biomedical engineering. And it was a presentation, I think, from Brown University, and this was like the first time I was exposed to this. And I thought bioengineering, where you can do medicine and technology at the same time, and design and engineering. And I thought, of course, this is what I want to do. And it was about the same time that I had gone back home. I think maybe in freshman year at college at Harvard, I had just gone back to Sierra Leone. And had a couple interactions with people who were amputees there, and they were amputees who had survived the war, and they weren't using their prostheses, and partly because it was uncomfortable, but everybody else assumed that they just did not want to use them at all, actually. And I came to when I came to Harvard, and I remember meeting a professor. David Ed was one of my mentors there very early, and he pretty much said, "Oh, well, we can't do what you wanted to do, which was work on medical technologies." And so I worked on TB vaccines then, and worked on a different energy lighting microbial fuel cell project. And 4 years after that, like in my senior year, I was having dinner with one of my friends, and I said, you know, I had this idea of working on prosthetics before, and they said, oh, have you spoken to Hugh Her? And I was like, no, I don't know who that is, but if you can introduce me. And so he introduced me to Hugh, Professor Her at MIT, and I met with Hugh, and I told him some idea I had, and we both decided that it was important to work on sockets because nobody was doing sockets at all in our group, and it is the most important part of a prosthesis.
The connection, so the interface between your residual limb and the actual prosthetic.
Because and the reason why that's important is if that is uncomfortable, it doesn't matter what the prosthetics is, whether you wouldn't use it if you have pressure sores and blisters, which most people actually have. Including himself. He's a double amputee, and so it was personal for him. He wanted to work on it. It was personal for me. So it had this global relevance and also local significance. So it had an impact in Sierra Leone. It had an impact globally. It was an interesting thing to work on.
David, before you started this project, were you a maker?
I think so. I never thought about myself as a maker, but I grew up being described as playful, which I will assume now to be a maker. It was very clear. I think if you asked my older brothers or anybody in my family, they'd be like, "Oh, moin that." This is what they call him, David. David, he's so playful, and I assume. I think it was equal to I was exploring, breaking things. The reason why I liked going to the theater was because Dr. Boima was using his hands, and I could stand there and ask questions and hold things. It was. I liked being hands-on.
Yeah, and so through this project of focusing now on sockets. So fast forward to David with the resources of this. You're at Harvard at this point?
I'm at MIT.
At MIT. So, MIT. So you have this, all the resources of MIT and the Media Lab and your playful spirit and your desire to solve this problem. So then what happens next?
It was about the time that 3D printing was just, because this was what, 2010. Right now, with these 3D printers are coming about and people are beginning to ask questions, they weren't necessarily structural for healthcare. And we decided that the only way you solve the issue for comfort, for human machine comfort, was by connecting human anatomy and modeling to design and to manufacturing. All of those three had to be done at the same time. For people who'd worked on this before, you either have somebody who's a medical imaging expert and they use MRI or ultrasound or scanning or different things to capture the human body, and they're really good at it.
Yeah.
Or you had somebody who was a soft tissue modeling expert, so they take measurements on your body and study what the force sits out with the displacement and whether it's viscoelastic, like what the creep is, and they can study that very well. And there were people who were good at design and they can use their computer and come up with some CAD structure. And there are people who were good at manufacturing. But there wasn't any bridge, there wasn't connection in all of that. There wasn't a continuous process that will go from imaging to a functional interface. And that is what we did. So a lot of it, I suppose, you wouldn't have been able to do in the past. And frankly, this is greatly due to one of my collaborators who built an open source framework on MATLAB, and it's called Gibbon Code, which allows you to pretty much do a lot of things with biomedical data. But for all the packages that exist, if I took an image of the human body and I wanted to analyze it in somebody else's different package, there wasn't a correspondence, there wasn't a continuation from this one software to this other software, to the design, to the STL generation for printing, to the manufacturing. And that was part of the problem, was was that there wasn't a continuation of processes.
Yeah. So it seems you had two parallel projects. You actually had to design the sockets, and then you had to design the system for.
Right. So to design the socket, we needed to design the system. You wouldn't have been able to do what we did without doing something custom that continued from the entire pipeline, throughout the entire pipeline. So from going from a biological body to a model that was predictive enough, such that if I pressed like this, I knew exactly what the deformations were, and I was able to capture that on the model, and I can use that model that I have validated and evaluated as a basis for the design. And from that process as well, whatever it is that I got should be able to go immediately to a printer for it to be manufactured.
Yeah. And so tell us, we're going to ask you one more question, and then we're starting to get questions in from the community.
Yeah, I mean, I guess I sort of have two questions that I would love to touch on with you still.
I thought you said one more.
Yeah.
One and a half.
Good. We'll do 1.5.
I mean, I guess maybe I'll go with this question because I think our community members would be really interested in this project that you have also been a part of. So not only are you doing this amazing work around prosthetics, but you also co-founded a nonprofit called Global Minimum, which I would love to hear a little bit more about the mission of that nonprofit, and maybe one of your favorite projects that's come out of it.
Yeah, so Global Minimum was a project that I did with my high school roommate, this guy, Jacob from Denmark, and another high school friend and his friend, just after high school in college. And the idea really there was, could we be able to enable young people to problem solve locally? Could young people have the required tools to be able to think about the problem that they were faced with, find the resources that they needed, including mentors, and took the first step, and then learn through that process. And as we've done it over the years, it's become more and more clear personally, and I think for the mission of the organization, that the world that exists today and the world that will exist in 25 years is one where we have to rethink about how we learn and the processes via which we learn to be able to not only survive, but also thrive. With climate change, with the violence that exists, and so the kind of hatred that's in the world, with food crisis, with border issues, the solutions that we expect from a classroom without having a hands-on experience are not going to give us the answers that we need to be able to thrive in this world. And if that is a reality that will exist in the future, and it already is the case today, then we have to rethink how people learn, how young people learn. The project specifically is done in Sierra Leone, Kenya, and South Africa as well. We've done this. And it was modeled after the MIT 100K and the Ideas Challenge, where you're giving feedback to people throughout the entire process. You're connecting them with mentors. You're elevating them. There are a million great stories with young people. But one of my favorites is where well, there are many, but one I love to share is this idea that once you enable young people to problem solve once, they just continue doing it. And in that process, if you allow them to participate in it, if you allow them to become mentors, peer mentors, it's the most viral way in which you can spread your effort. So one of those kids, Mohammed Hadin, who's in South Africa now at the African Leadership Academy, had worked with us in GMIN in Sierra Leone, and emerged as this peer leader with Kelvin Doe from the video. And they will go to assemblies of schools to talk to people, to encourage them to make and learn from making. And then Mohammed Hadin, once he went to African Leadership Academy, continues to mentor dozens of other students on the platforms that we have. And Mohammed opened the lab in his own house, right? So the first lab we opened was at his school. we had a bunch of kits that we'd bought. And then he had his own lab at his house where young people were coming. Now, fast forward 2-3 years later, one of those students who came to Mohammed's lab had his own lab in his own house and was also one Innovate Salon person. And the kids who came to his lab had no direct interaction with us. We didn't even know that. And our only interaction was with this kid, Vandy, who now actually is also getting a scholarship. And so it's this peer mentorship and peer support that I think is really wonderful that's come out of this. And you see people civic leaders. It's really that from making and learning to make. You're not only learning and solving problems, but by so doing, you're becoming a leader. You are a leader in your community.
Yeah, no, that's so interesting. So I feel like really the beyond prosthetics, like the meta project of your life has been democratizing access to innovation and then using making as a gateway to civic engagement, civic empowerment.
Yeah,
that's a better way to say it than I would have said it. But I think you're right in the sense that with prosthetics, it was about the physical body, and it's about creating interfaces that will enable people to go beyond what they could possibly have done, right? So it's about opening up potentials. It's about making them to be comfortable. And with Global Minimum and the work we do, it's about it's freeing the mind. It's about becoming a leader in your community and problem solving. So it's both the physical body and the mind, I think. You're right.
Cool. Nice. Okay, so should we take some questions?
Yeah, let's do it. Ooh, I feel super inspired. That was great. Okay, so let's see. We have Chloe and Jude and Nick pulling some questions for us. So let's start with an easy one. So how long have you been working on this project, on the prosthetics?
In thought, like just by thinking about it, I will say since 2006, so just before freshman year in college. But I didn't actively work on it until my master's at the MIT in 2010 was when I started. So the first multi-material prosthetic socket that we made came out in 2011, 2012, and then so 5 years. 5 years with.
Do you know how many prosthetics you've made to date?
Oh, a lot. That's including all of these 1 million that have been made and failed and broken, and it's part of it. I think that's also what's great about digital fab, I suppose, is you can test and evaluate things. And sometimes you know they're gonna break, but you still make them and watch it break. Right?
Yeah, gotta break it to make it.
Yeah. Okay, so let's see. Another question we have is, do you know about how many patients are using these sockets right now?
Not outside the lab, and parts of it is because we're still getting this process nailed down, where you go from, and we're trying to reduce the cost more and more. So nobody's using it outside the lab, but I have worked with about 10 people in the lab who have tested and used this prosthetics in the lab.
Cool. And then another kind of simple one. So what material do you use?
Right. So one of the 3D printing techniques out there is the polyjet, the inkjet printing, and it's multi-material, and it's 2 nozzles that are connecting a rigid and a really flexible material, and it's by Stratasys, so we use those materials and we can combine them. And the reason why we want to do this is to test this hypothesis around the impedance, almost of the response of the body versus the response of the material that you're against it, right? Because the hypothesis there is you want to minimize these internal strains and stresses and and lower pressure on the body, because it leads to internal injury. And the way you do that is by using flexible materials over rigid regions of the body, and one of the ways to do that. So it's mostly been the 3D printed printable materials.
Okay, we have a question from a biomedical engineer, right?
Good.
Okay, so he's a biomedical engineering student. Do you have any tips for students to start off their own projects in parallel with being students? So how do you manage that?
Yeah.
I think in undergrad, I had to be comfortable with not getting an A, right? And I was absolutely satisfied with the B plus if I got a B plus. And one.
Notice we did not ask you what grades you got.
That's good, because you have learned.
Okay.
Well, because parts of it is there's this instance where I had an opportunity to go to Paris in my sophomore year to speak at this conference, it was a hands-on global health thing. But I was taking physics at the same time, and you can't miss the problem sets. And I emailed the people when they're like, you have to turn in all the problem sets. You can't turn it via email. And I had this long conversation with my dad, and it was like, you have to stay and do this physics thing, it's blah. And I was like, no, I went to Paris. The relationship I had in Paris and the people I met, the global health leaders, have remained great mentors of mine. They are absolutely been instrumental to me the entire time. I got a C in physics, that particular physics, and I have a PhD in bioengineering. I don't think anybody matters with that. But so I think for students, it really is a question of what are you knowing kind of who you are and what you're capable of, and being satisfied and happy with the decisions you're making. For me, I always wanted to live every day knowing that, and my lab mate, and I have a lot of conversation about this. If I died tomorrow, I'm absolutely happy with all the life I have lived up to today. There's nothing that I am waiting to live for. And so all the decisions that I make through the projects that I work on are projects and decisions that I'm absolutely satisfied with and feel like I should be working on at this very moment in time.
Wow, that's a high bar.
Yeah.
But anyway, get on that plane to Paris if you get that ticket.
Just trade-offs, just understanding trade-offs.
Okay.
It's important. Let's see. Okay, so maybe we'll do 2 more questions. Let's go with this one. So this listener says, thank you for your beautiful presence, David. Can you elaborate on the mentorship aspect of the project and connecting people in different countries?
Yeah. I think for me, it's the most important part, right? This relationship that you have with other young people or with your co. And the one first thing is this mentorship thing is equal. I mentor my students a lot, but I expect to learn from them, or in that interaction, I'm learning from them. It's not just one-way street. And once you have this equal and respectful relationship, they get more, you get more out of it, and you mentoring them makes you want to do more. I think one way will just be to send an email to info@gmin.org, so info@gmin.org, and we'll respond to you. The many ways in which we do it, right? So here's a funny story, true story. I was asked to give a talk in Helsinki for the UNICEF Innovation Summit that just happened there. And I couldn't go because I was doing my defense and all of that. And then I said, oh, but we can bring some students from Sierra Leone. This was about 2 weeks before. They were like, we don't know. Okay, sure. And then we went back to our kids and we chose 3 students who had never applied, who'd never traveled. Great group of students. And they were going to come to Finland, but there was no Finnish embassy in Sierra Leone.
So they had to 3D print one.
But the other way to do it was they had to go to Abuja, and then planes don't go between Abuja and Sierra Leone all the time. So they went, left their passports, came to Sierra Leone. Anyway, they had to leave by like Monday, and the passports were not there. They were still in Abuja on Wednesday, and the only way they could get it was by me calling one of my former housemates who was in Lagos, who called somebody who picked up the passports from Abuja, who flew to Accra and gave that to somebody else who we'd met, and brought that to Sierra Leone and gave it to them, and they exchanged the airports and the hubs and their planes to Finland. They went to Finland, great. But I think with regards to mentorship and being available, there are many ways in which people can be helpful, from carrying a passport from one person to another, to helping any one of our students with their ideas and so yeah, shoot us an email.
Right on. Cool. All right, so I think we're going to take our last question. Okay, so it says, sometimes playfulness and tackling serious problems might be at odds, at least on paper. How do you, I guess this is kind of a separate question, but I like this. How do you incorporate play both in your process and in the actual product?
But I like the person said on paper. But so on paper is different from in practice. In practice, I haven't felt like they have been at odds. The idea of play, the idea of being happy with what you're doing, the idea of being in a state of calmness and enjoyment need not be in practice at odds with serious work at all. I never, I don't believe that they are at odds. But
every time you've told a story today, it's always with your lab mates or other people. It's about, there seems to be this basis of friendship.
Yeah, and I like people. I like people.
And playing together.
Yes, it is absolutely important. You can't do. I don't know. There are some people who work best alone. Yeah. I do not work best alone. Or I like to share my ideas and I like to develop it and go back and forth and grow from there. But in terms of design, I think design has to be open for it to be democratic. Design has to be, in the tools that we create must be, so for all the tools that we use for the prosthetics work are all available on Gibbon Code and are all open source tools. And you want that to be the case because you want people who can't afford those packages, the software, to be able to use whatever it's there, to solve their own problems, to do things. So I think design has to be open source as much as possible. I also think that there needs to be a continuation for whatever work area you're doing, a continuation of data, right? So for me, it was important that you can take an MRI and use that image data to build a model and use that modeling to do a design and use that design output to build the socket. That needs to happen a lot more with designs, especially for biological solutions.
Yeah, it's about getting access to the content and conduits.
Yeah.
Cool. All right, so should we open up the chat rooms?
Yeah, we should. Well, let's say a huge thank you, David. This has been
wonderful. You so much.
Thank you. It's a lot of fun. I do have a lot of love for littleBits for multiple reasons, but.
Oh, can you share mine with us? Sorry.
Apart from it being the AI is a wonderful person, but right. But one of the things that I was sharing with Nick that I really look forward to is using the musical kits that I had seen to work on a beat and flew with it. So.
Yeah,
I like the broadness of things that you can do and the expansiveness of solutions that you can get, right? And it's very playful, and that's key.
Cool.
Play.
Okay, we'll keep playing. Thank you so much, David. We love you. Thank you so much.
Bye.